we have gone through the analytical definition with the graphs for the increasing and decreasing functions, for strictly increasing and strictly decreasing functions. Now let's move for the strictly increasing function with the example. Okay, now we have already gone through the definition for the strictly increasing function. I am writing once again a function is said to be strictly increasing function on an open interval a comma b. Suppose we have given open intervals on an open interval a comma b if now what the condition was, x1 is less than x2, and this implies a function fx1 is less than fx2 for all values of x1 x2 belongs to a comma b. Okay, so this was the definition which we have already done it, and I have also shown you a graph for that. Now let's discuss an example. Show that let's write it example. Fx is equal to 4x plus 5 is a strictly increasing function. Now how to prove it? Okay, so we will be writing, let x1 x2 belongs to I, or we can write it any given interval, suppose it is a and b, belongs to an I, then x1 is less than x2. Okay, then we are having x1 is less than x2. Now multiplying both sides by 4, 4x1 is less than 4x2, and adding 5, 4x1 plus 5 is less than 4x2 plus 5. Okay, so here we can write it multiplying by 4, and here we can write it add 5. Now 4x1 plus 5 is what? It is the given function. So we are having now fx1 is less than fx2. Therefore fx is equal to 4x plus 5 is strictly increasing function. Now analytically once more let's solve it. Now suppose we are having suppose x1 is equal to 1 and x2 is equal to 2, then f1 will be what? f1 is equal to 4 into 1 plus 5, and that is 9, and f2 will be 4 into 2 plus 5, that is 13. So clearly 9 is less than 13. Okay, clearly 9 is less than 13. So that's why we can say it that if x1 is less than x2, then this function is strictly increasing function. Okay, so we can move with the very simple conclusions.